Hello student, Assalamu alaikum. Student, this is numerical of chapter 2 Kinematics, and this is numerical of this numerical is included in smart syllabus grade 9. So the question is this: the ball is dropped from a tower, from the top of a tower. Suppose this is a tower. Okay, a ball is dropped from the top of the tower. The ball reaches the ground. This is ground, and it reaches the ground, and it take 5 seconds. 5 seconds. Okay. Find the height of the tower. We have to find the height of the tower. We want to find this. And velocity when it reaches the when it strikes the ground. When the ball hit the ground, we have to find its velocity. So this will be velocity will be final velocity. We have to find. So write the data. Time is given. That is 5 seconds. We can write with small s. Okay. And height. We want to find height. So here we have final velocity. We want to find that velocity when ball hit the ground. So this will be final velocity. So our initial velocity was 0 at top, and final velocity we want to find it. And as there is they are saying we have to find the height. So there is gravity value, acceleration due to gravity is there. Acceleration due to gravity or gravity value, that is g, and its value is 10 meter per second. I hope it is visible. 10 meter per second. 10 meter per second. Otherwise I write with black. To find. They two things they ask: height and velocity. So height, that is h, and velocity, that is final velocity, vf. Okay. Now we have three equations of motion. First is this is rubber. Vf is equal to vi plus at. Second equation is s is equal to VIT plus half AT square, and third is 2AS BF square minus VI square. As I is concerned about height, then acceleration change into gravity, that will be G. So we will replace these equations into this way, okay? And this equation S will change into H, VIT plus half GT square. Okay, and this will change into this. So now we have these equations, and other equations are also this, but we will use this. For we have initial velocity, we have gravity value 10 meter per second square, that is constant, and time is here. We can find final velocity with this, but this is the second part. So we will use for second part this equation for finding the final velocity, and now we have two options. Either we will use this or this. We want to find height. You can use both equations. I will use this one for A part. Okay. Now for A part, that is for height of tower, h is equal to VIT plus half GT square. Put the values. Initial velocity is 0, time is 5. Second half, and g value is 10, and time this is 5 square. Okay, this will be 0, and now half into 10 into 25. 10 5s are, and then 5 into 2. So it will be 125 meter. Now second part is final velocity. That is Vf, first equation, Vf is equal to Vi plus Gt. So Vi is 0, G is 10, and time is 5. Vf is 50 meter per second. Student, this is your answer. Vf is 50 meter per second. It is visible, yes. Now here you have concluded that when we want to find this height of the tower, either we will use this or this. If you are doing first part, you can use this equation because there is the initial velocity is given, that is 0, and g is constant, time is given. So you can easily find height by using this equation. You can use this equation if you know the value of Vf. But in second part we have solved this. You will solve first. You have to find for, if you are using this equation, you have to find the final velocity. Then you can put the values final velocity over there, and you can find height of the tower by using this equation. Otherwise, you have to use this equation, and you can find height of the tower. You can use this, but before it, you have to find the final velocity. Then you can use.